All right, we're gonna look at also, scratch those two out, for example 4. Try example 4. These are supposed to connect here at -3 and they go up. It might help on some of these if they're going up to use the arrow on here and then the arrow on that one. So again, look at your domains on the left and then on the right. So it's kind of different this time. And it's low there and high there. So we have this gap in the middle this time. So that means the x values go for a little bit and then they stop. They don't go to the middle part and then they pick up again. So when we write this, I write these as two separate parts. So the domains, -infinity to -3. Infinities always get the parentheses. -3 gets a bracket. Now I skipped that part, so I'm gonna stop it there. You can use a union, which means and, or write and. Now I'm gonna pick it up again when I go to the right here, 3 to infinity. So if it's in different sections, just write it individually for those pieces. For the range, I'm looking for how far down does the graph go and how far up. So I'm talking down to a 0 on the y-axis and up to infinity here. All right, example 5, you've done this before where you determine if it's a function or not. So we are looking at these to see, do they pass a vertical line test, which means, do they pass through the graph if I draw a vertical line anywhere on here? If it passes through the graph more than one time, it is not a function, which means each input has more than one output. So you would be looking at something like 2 goes to, what, 5.2, and then 2 also goes to -3.5-ish. You can't have an endpoint have more than one output to be a function. So when I look at letter B, everywhere along this graph, it might curve, but it only goes through the vertical line anywhere I draw it on there one time. So yes, function. Each input has one output. And this one in here. Now I have a gap in the middle, which is okay. I'm just checking vertical lines here. And it's a yes, it's a function. Each input has one output. The last thing we are going to be doing are functions to determine where it is increasing, decreasing, or constant. You always want to move left to right. So when I'm starting on the graph here, I'm kind of following it here and I'm saying, okay, it's going down here. This is a decrease. It breaks there. Going flat is a constant. Going up to a peak or a vertex is an increase. And then going back down is a decrease. So similar to what you had up here when you had more than one value, one input, one that sort of stuff. You may have multiple pieces, multiple decreasing, multiple increasing. You may have none, depending on what the picture looks like. Now for this, we always use x values. Always, all we are looking at are the inputs. We don't care about the y values. And only use x values and only use parentheses. Because I'm going to have numbers repeating. I can't have a number that's in the increasing and in the constant, or in the decreasing and increasing. So when I'm looking at these on the next page, I follow the graph from left to right. So I follow it up, up, up. So I'm following it this way till I get to a part where it kind of stops or breaks here. That from here to here is an increase. Sometimes it might go down after that, which would be a decrease. But when I keep looking at it, that's increasing too. So actually the whole thing is increasing. So I want to look at these breaks. So the first one here and the second one are going to look a little bit different from each other. Okay, so increasing, I'm looking at my x values. Increasing from -infinity to all the x values and all the x values, -infinity to +infinity. there's no decrease part here. There's no flat part here, so no constant. All right, as opposed to this next one, when you look at it, if when it goes up and hits this peak here, this vertex point, it is an increase. And then it's going to slide back down here, and it's going to be a decrease. And then it's going to go back up here again and be an increase again. So I'm going to use my x values here. I go from negative infinity, this break is at -1. This break is at +1. And I keep going towards infinity. So I have increasing first, so I go from negative infinity, was at -1. Now remember, all of these get parentheses because look at the next thing. When I go to a decrease here, I'm going to have a -1 to a +1. I can't have something be in bracket here and a bracket there. It can't be included in both sets. So -1 is kind of like the stopping point, so it's parentheses where it breaks and switches from one to the other. It's called an inflection point. And then from here, again, same thing here. 1 is used on the decrease part, but it's also used again increasing. So I put 1 here and to infinity. There's no flat part, so no constant. We're going to graph piecewise tomorrow together, so that means your graph is going to have individual sections to it. So we're going to do this tomorrow. I would like you to get done for tomorrow page, so this first one is from numbers 1 and then stop here. So let's see, this is going to be, sorry, I don't have the page numbers in front of me. 1, 2, 3, 4, 5. So my guess is it's on page 5. So look for day 1. I'm guessing page 5. Do numbers 1 so the front page, numbers 1 through on the back here, and then we're going to stop because we're going to do the piecewise tomorrow. So let me know if you have questions. Thanks. Bye.